I hope you can all hear me. Thank you for the great introduction. I'm going to basically start by providing some context. Last year, I spent a great amount of time in Rwanda teaching classes and also traveling for a project we had there. And one of the things that struck me when I landed in the airport and started going around was there were a lot of signage about 4G networks and getting connected. And um, much of this wasn't really weird. I think the weirdest part was it was all about 4G plus. They had just gone 4G plus a couple of years ago. While I was there, there were several outages, and these outages essentially had a huge impact. By my second week there, I think I was fully plugged into the ecosystem. All of my transactions, so if I went to buy groceries, was through mobile payment. If I wanted to buy uh, connectivity, top up my internet was mobile payments. If I wanted to buy electricity, top up my electricity was also mobile payments. So I was plugged into this mobile ecosystem. And by, I think, March, there was a huge outage and I could not access many of these services. So basically, I was unable to pay for my driver. I was unable to pay for groceries. And as you can imagine, this becomes quite frustrating. And a lot of what we've been doing since then is to try to understand what are the challenges that impact a lot of these digital public services. We're all adopting digital services, but when an outage happens, then we start to lose sight of these services. And it's not exactly clear why. In many of these countries, they've adopted EU-style laws where there's data localization. So it's not just about localizing the data. There's something more we need to think about in terms of digital sovereignty. So that's kind of the context for this talk. And jumping into it, I wanted to provide a high-level background on what are these subsea cables. I think in general, we don't often think about these subsea cables. There are a whole lot of them spread out across the world, and there are um, many studies that show that roughly 99% of all traffic goes over them. And this is why John said you cannot just switch from this to Starlink. At this point, Starlink cannot support 99% of the capacity. And with the adoption of AI, more cables are being laid to support more and more data. And so these cables are essentially crucial. And while they're crucial, we don't think about them until an outage happens. And going back to the context I had last year, a lot of the government services are hosted in Rwanda. They're hosted downtown, which is kind of this right here. And I stayed on this other side of downtown. And when we lost connectivity, one of the things that happened is we had conversation with several um, employees of the ministry. And there was a question: data centers are downtown, people are all around. Why, why are people unable to connect to these services? And this is one of these things where there are laws in place for localization, and increasingly, these laws do not account for external dependencies. And I'll talk about these external dependencies in a little bit. But because these external dependencies are outside of the country, they're not in the data center, when a cable cut happens, you essentially use access to these dependencies. And these dependencies are crucial. Without them, you cannot actually access your data. And so when we have a cable cut, we're not able to access this third-party services. We can access the third-party services. We cannot access our data. And so essentially, there's a lot of these outages that happen. Now, when we engage with the same entities, there's this question of how do we expand our laws to include AI data centers? And one of the things we are trying to bring up there is similar to how data localization does not address a bunch of other things. Just bringing data centers to regions of Africa doesn't address a lot of what is required to make it an AI first ecosystem. And I will not talk about that in this talk. I'll focus more on the infrastructure and the subsea cables. But I think there's kind of a parallel in terms of when we think about how do we ensure that Africa is not being left behind from an AI perspective? It's not just about putting AI data centers. There's more that needs to be considered when thinking about that problem. Um, but coming back to this, so when we were engaging with the ministry, one of the things that became clear was we need to try to educate people about what are these dependencies, how do these dependencies interact with trying to get access to your data. But also when we think about digital sovereignty, it's not just about your data itself, it's about being able to access it as well. And one of the big things we've been trying to push on since the second half of last year is how do we start to define access policies? How do we start to define regulation that consider access to the data and not just the data itself? And so the later part of this talk will be a question that we've been trying to answer in terms of how do you regulate access? How do you regulate resilience? Specifically from the perspective of subsea cables, I think there are many layers you can consider in terms of access. We've started out with a subsea cable component because that has been very crucial. And it actually continues to be crucial, as we saw with Pakistan last week. So in terms of the overview of this talk, I will start with some context about the subsea cable cuts and why they're crucial, or more specifically, how they've been more crucial in Africa. Then I will spend a huge amount of time talking about these hidden dependencies. And then I will conclude about discussing resilience policies. And I think while most of this is focused mostly on Africa, a lot of what we discuss here, I think, applies to other parts of the global south. With the outages we saw last week in Pakistan, I think there's the question of how do we think about resilience over there. There's a similar question in terms of how do we look at this in the context of Latin America as well. Much of what I will be doing here will be discussing data that we've collected from publicly available data sources. So we've used Cloudflare's radar, which provides us with outage information. We've used AppNix DNS data, which provides us with information about DNS, which is one of these dependencies that are crucial. And then we've started to use data from telegeography, which provides us with maps of these subsea cables, allows us to understand where they are, but more importantly, it allows us to identify correlations between them and allows us to think about resilience from a redundancy perspective. And we have other analysis where we've been using data from RIPE and Google's MLab to try to characterize connectivity. In this talk, I won't have time to talk about that later data set. So kind of thinking about outages themselves, one of the things that we've been trying to highlight is a lot of these cable cuts, they happen everywhere. When you look at Africa, it has a bigger impact than in other places. And it has this bigger impact because of how the ecosystem is in Africa. Essentially, there are a few number of these landing points where we have these cables, but more importantly, within the context of sub-Saharan Africa itself, there's a huge dependence on data that is stored in Europe. And there's a huge dependence on services that are stored in Europe. So when you look at number of countries impacted, you will often see that there's a larger impact in Africa just because of this dependence. And kind of to make this clear, when there is an outage in Africa, it has a high likelihood that it's going to impact many countries. On average, it impacts basically about 3 countries. In the kind of worst case, which is what we saw several times last year, it impacted between 9 to 12 countries. Whereas in other places, there's kind of a one-to-one correlation. There's one cable cut, it impacts one country. Whereas things are very interconnected in Africa, and there's a high dependence external. So when you look at these cable cuts, they will have a bigger impact. And this is one of the reasons why there's a huge focus now from the ITU and from many other agencies look at these cable cuts within Africa. And I think one thing that people find a bit weird is when you look at outages elsewhere, we tend to recover quickly. There was an outage in Spain where it recovered in less than a day. You look at these cable cuts and they take a lot longer. They take, in theory, the cable cuts themselves will take months to be fixed, but recovery will take on the order of days to perhaps a week in some extreme scenarios. And this essentially happens because these cable cuts, unlike the other outages that we're used to seeing elsewhere, there's a power outage, power comes back, the lines get fixed. The cable cuts require ships to go out, require negotiations to happen, and require a bunch of regulatory approval. So cable cuts, when you look at them within Africa, they have a huge impact because of how interconnected things are, and they're very slow to repair because of just their general ecosystem. And this means that these outages that happen will have significant impact. I think we look at one of the ones that happened last year in West Africa. It basically was a multi-day event between 3 days to perhaps, I think, over a week in some countries. And it had cost hundreds of millions of dollars in terms of revenue, just because many of these countries had adopted many digital services. And when they had lacked connectivity, they were not able to access much of these digital services. So kind of transitioning now from why is the impact large and why is there a need to try to focus, I wanted to kind of go into what is the challenge, what are these dependencies, why do we often forget them, and more specifically providing quantitative data to understand why these dependencies have such an oversized impact. So this is a slide I often use at the beginning of a networking class. It's basically, how does the internet work? You can imagine that you're a client somewhere on your browser having a good day, sipping a latte or a coffee, and you want to go to a website. And let's say you want to go to afpif.com, which is one of the largest peering forums in Africa. First, you need to essentially do a lookup. You need to translate from afpif.com to an IP address, which is an address that the network understands. So to do this, you go to DNS, a domain name service, and then once you get that, you can then go to the data center to get the data. And one of the things that's quite interesting about the way the internet works is we have these layers of abstraction, and these layers of abstraction hide many interesting parts from the end user. The DNS is one of these many layers that hides something that's crucial. There are many others that also hide crucial aspects. The sad part is, jumping ahead. So the sad part is when you lose access to DNS, then you're not able to go to the actual data centers with the content. Essentially, without the translation, you can't get content from the data centers because you don't have an address that the network understands. And similarly, if you're able to get this translation from the name to an address, but you're not able to access the data center, you can't get the actual data itself. And there's kind of this other parallel where if for some reason your route needs to go over a subsea cable to get to either of these, then you will not be able to access it when the subsea cable disappears. So there's this nice layering that hides information, but also there are these dependencies built into these layers, and you essentially need all of these layers to work together, work correctly for you to be able to access and use the internet. And it's these hidden dependencies that are not considered when people often think about what should we try to regulate. And it's these dependencies that have kind of essentially crippled a lot of the countries involved in these outages. And one of the things that I think was crucial for us was to provide quantitative data for each of these different layers. I wouldn't go over all the layers in the talk. I'll only go over a few, but there are more of these layers and we have some data and we can kind of show both at the continent level and as well as at the country level, how much of the dependence is local versus remote. So one thing I like to start out is just looking at content itself. And this is something we did last year with ISOC, the Internet Society. And the idea was to try to quantify what fraction of traffic, what fraction of your actual content and traffic to that content is local versus lives the continent. And here we have data for about 3 different countries: South Africa, Kenya, Nigeria, which happen to be 3 representative countries from different regions, but also highly technologically advanced. And one of the things from here that you can basically see is there's clear differences in the distribution in terms of how much adoption exists. And so you look at the case of Nigeria, which is in West Africa. So there, basically over 90% is remote. The cable cuts in March were in West Africa, and that basically took much of West Africa offline for many days. And kind of looking at the content layer, it's basically many things are remote. And so when you lose access to content, then it becomes a challenge. Looking at DNS, which is one of these application layer services across the different regions, we'll see varying levels of local versus remote. East Africa here has kind of this high notion of remoteness, similar to Central Africa here. And the second outage that happened in March last year essentially was East Africa. And there is where the Rwanda example, a lot of things are in the capital, but we're not able to access. And here you start to look into why, even though the data is local, one or many of these application services that are required are not. And so it's essentially one of these things where you cannot access DNS, you cannot access data, and you're not essentially able to use connectivity itself. And so as we start to look across many of these outages, you can essentially tie it to a member of this ecosystem being remote. Actually, it's actually one or more members of this broader ecosystem of network layers, protocols being remote, and this remoteness preventing you from accessing the data that might be local itself. And so here we've started to think about, as I said earlier, resilience isn't just about individual components, it's about all of these layers. It's about trying to think through the holistic picture. And one of the things that became crucial as we started to travel around at conferences last year, and as we started to talk to different regulatory agencies, is that there isn't one solution that works well for different countries. Each country has its own profile in terms of the type of remote services it depends on. And so when you start thinking about policies, when you start thinking about intervention, part of that has to be tailored. I think the fundamental concept about looking across the layers translates, but which layers are crucial, which dependencies are crucial varies from country to country. And I think a lot of what we've been doing this year is rethinking this notion of digital sovereignty. A lot of conversations across the continent is still focused on data, specifically localization, and more recently growing to look at AI data centers. And what we've been trying to pull back into the conversation is this notion of infrastructure, network routes, application services, content servers, subsea cables. All of these are required. So data and the data centers, they provide you with access, they provide you with compute. Sorry, data and the data centers provide you with content, provide you with compute, but there is this hidden layer of infrastructure that is required to access either the data, access the AI data centers themselves. And so there's a question in terms of how do we start to think about regulating this hidden component, or this component that's often overlooked, and what is the right way to get the data to enforce these policies. And so the next part of this talk is essentially thinking about resilience and these policies. One of the things I joke about is that a lot of what we've been doing has been extremely timely, but not by design. We started out last year looking at measurements. I decided to go to Rwanda long before I knew there were going to be subsea cable cuts. And we happened to have a bunch of these measurements and this data, and that has helped us out in many of these conversations. And now that there are entities looking at trying to regulate much of these challenges, we are, I think myself or a member of the group is on several of these working group or advisory bodies. So I'm on the ITU working groups look at monitoring and resilience. We are now getting funded by ICANN to essentially try to deploy measurement infrastructure across the continent to try to better understand connectivity and understand resilience. And one thing that's very clear in many of these conversations is that it's not clear what to do. And I think even for myself, I thought I had a very clear idea of what we would do. And as we've tried to do it, it has become clear that we are also unsure of many things. And so we've been learning a lot. And part of what I'm going to talk about next is some of what we've been learning. So I think the obvious question is, what should we monitor? And when you talk to most people, they'll start by saying, look at IXPs. These are things that many people have focused on as they try to look at data localization. If you ask my group, we will talk about, let's look at these subsea cables because this is where a lot of these challenges are. And as I've talked during this talk, there's this notion of these application services, this hidden dependencies that we also need to try to look into. I will talk about the challenges with the subsea cables just because that is more relevant to the talk, but we actually have publications recently looking at challenges in the IXP space, and we're slowly looking at challenges in the application services space. So subsea cables, how do we measure? Okay, I guess before I jump ahead, one thing to point out is that ATU and several other entities are also looking at this notion of what is resilience, what should we be capturing? And I have a figure from their most recent taxonomy, which I believe should be out later this year. And a lot of what they align as critical infrastructure maps with what we are looking at. The one thing to try to point out is that these application services is one thing that's not directly mapped into their ecosystem. Another thing is we do not have power in ours yet. But I think that we are in conversations with them, but there is complementary aspects where we are both thinking about resilience, but there are things that we're both missing out from right now. But I think the broad idea of showing this is that there are other agendas going on in terms of resilience. We are in conversations with them, and there is a huge amount of overlap. And the goal is not to work independently, but to actually try to work together. So jumping back, how do we define resilience right now? We define resilience in terms of redundancy. So you can't really see it on the screen, but the PDF that I've taken a screenshot is from Ghana, and it's basically their policy in terms of how do you define resilience. And many countries have realized subsea cables are a challenge, and they do have policies. They define policy in terms of a redundant provider. So each network provider needs to have a redundant network provider in the country that provides them, in theory, to access to a different subsea cable. Or each network provider in the country should have a redundant provider outside of the country, which in theory should provide them access to a different subsea cable. So these are the kind of policies that you'll see. Is basically resilience means redundancy. Define redundancy in terms of network providers, and given enough network providers that you have, then you will have access to alternate cables. And so I think many of these policies are now being revisited after last year. But the one thing that was interesting is when we looked at the subsea cable graphs and the maps from telegeography, um, the first thing we observed is that even when there are many cables going through a country, all of these cables land in the same location. So for 40%, there's just one location in the country where all the cables go through. Um, at the median, it's basically two locations. And so you have all of this redundancy at the uh, network provider layer, but physically they're all going through the same beach. And this is what we see when we see these subsea cable cuts, is that there are many cables going through the same physical locations. And when a anchor goes and drags and cuts down, it will cut many of these cables together. The other thing we saw when we looked across the countries is that when you look at a neighbor, um, any of the neighbors in Africa, they only provide you access to one or two extra cables. So basically, the second graph here is the number of cables at each country, and the difference between the two lines is the first line is uh, cables based in your country, and the second line is additional cables based on your country and the neighboring country. And there's a basically very small, narrow set of additional cables that you get by looking at your neighbors. So when you have policies that are just, let's be redundant in terms of providers, physically there isn't as much redundancy, and essentially you will have redundancy in terms of providers, but physically it will be the same cables, or it will be cables that are co-located. And so essentially when there's a cut, either because it's the same cables or physically co-located cables, you lose connectivity. And here, one of the things we've been trying to push through with the ITU is trying to think about resilience is redundancy, but not just redundancy at the network provider layer, but also trying to define redundancy at the physical layer. Um, and the question naturally from there is, how do we monitor this physical layer? How do we monitor the subsea cable layer? And as an academic, one of the things I told my students is basically, this is a solved problem. There are many academic papers. We can pick one. End of the day, it's very clear. There's a set of addresses, that's a data set that we scan for. There's a software that allows us to scan. And then we just run the software. And this is not essentially how it's going to work out. One of the things we discovered is that when you take, one of these amazing papers, they provide you with a great level of insight into how the network works. But from a resilience perspective, from a policy perspective, what you want isn't just great insights. What you want is actual quantifiable information. So here I have one of these very interesting papers that appeared a couple of years ago. It's been cited and used by other papers, and it's also in many blogs right now. One of the things we observed when we try to apply it is that essentially it maps network paths to many cables. And in some cases, it mapped a network path to as many as 40 cables. When you're trying to determine what is the cable that this network path goes over, you don't want a mapping of 1 to 40. You want a 1-to-1 mapping. When you're trying to decide if someone is in violation of policy, this 1-to-1 mapping is crucial to decide whether they are in or out of policy. And we've looked at many other papers in the space. And one of the challenges is that at the network layer, many things are hidden. So physically, subsea cables go into beaches. Turns out that most of the network layer hides the beach level infrastructure. Most of the geolocation services do not work well at the beaches themselves. So a lot of what we see at the network layer at the geolocation is the next biggest co-location center to the beach, which is where all of the cables go into and where a lot of the network layer information starts to get created. So there is a lot of work that needs to be done in terms of how we do monitoring. And more broadly, one of the bigger challenges that has come up now that we're in conversations is there is a need to do something. Uh, to do something, we need to be able to accurately predict what is the impact of the changes we make. And it's been challenging to do this. So we talk about domain name service as being crucial. There's been a question that has been asked is, can we add more? And the answer is obviously yes, but in adding more, it's not clear that we can predict what will happen. And this is interesting, and this is a bit unexpected because when we look at how do we add more of these domain name services in Europe or in America, it's very easy to predict what is the impact. In Africa, when you add more, it's not easy to predict. And one of the reasons why is because when you look at how traffic works, fundamentally traffic itself goes outside of um, outside of Africa. So I have a graph here, and the graph is basically between 2 points in Africa. When you try to send traffic from one point to another, both in Africa, what fraction of that traffic leaves? And the light blue is the amount that detours outside of Africa. And so because there's a huge amount of this traffic that essentially detours, and it varies from country to country, the performance models we have makes it extremely challenging to try to predict placement. John, I see you have a question, and I suspect that means I'm running out of time.
We do need to wrap up if you can hear me okay.
Okay, yeah, this.
Thanks.
So there's this question about how do we do prediction, and that's also something we're looking at. But more generally, a lot of measurement infrastructure and a lot of measurement tools that we have need to be re-tailored and considered within the kind of ecosystem that exists in Africa. And that's one of the things that we're working on. To do that, there's also a need to collect data. And so we are creating a bunch of these devices, and we're slowly deploying them now to try to collect more data. And there is kind of this need to think more systematically about alternatives. So subsea cables are crucial, but there are alternatives like, as John mentioned, Starlink. There's also this question about other terrestrial cables. And we are trying to create simulators that allow us to understand how these alternatives work. And so our vision is to essentially create both models, a large deployment, and a set of simulators that allow us to rethink how connectivity works and allow us to start to shape the broader conversation around digital sovereignty. I believe my contact is on the website. If you have any other questions or if you're interested in collaborating, please reach out to me. Myself and other members of my group are definitely eager to work with more people and essentially grow the set of people addressing these problems. And with that, I will conclude and hand it over to John.